Hello everyone, and welcome to our presentation on enhancing emergency response exercises, the role of the ROV simulation in emergency response. This will be a joint presentation. It will be delivered by both ourselves at OSRL and GRi Simulations. So a little bit about GRi. GRi has been providing customized simulation support for offshore well emergency response or offshore emergency response operations since the early days of the subsea well response project. And they've developed a range of ROV simulations that cover the installation and operation of much of the equipment in the OSRL SWIS toolbox. So my name is Fazio. I'm the OSRL Global Integration Manager for Response. I have over 25 years in crisis and incident management and source control, enhancing subsea capabilities, source control, emergency response. So also presenting from OSRL is Morry. He's our subsea manager from the Americas. He has 30+ years in offshore construction. Brett is a source control subject matter expert and a patent holder and a contributor to IOGP and API. From GRi Simulations, Desmond Greene is a project manager who has overseen the development of GRi's emergency response simulation toolkit since its initial development over 10 years ago, and has recently been managing GRi's research and development projects focused on digitalization for marine energy asset and land-based mining operations. Neil Noseworthy, also from GRi Simulations, is another experienced project manager who oversees GRi simulation content development efforts. So Neil will be running a live simulation demo a little bit later on. A quick overview of what to expect first. We'll provide you some background on how GRI software can be used to provide an immersive, effective ER training experience. And then we'll follow that with software demos performed by Neil. We'll leave about 10 minutes near the end for any Q&A or comments you might have. So without further ado, I'm going to hand over to you, Brett, and let you kick off the session.
Great, thank you. If we could go to the next slide, please. So OSRL preparedness services. Acting on our internal directives to improve our preparedness services, we are offering these ROV simulation services to add value to your exercises. Leveraging our existing industry relationships, GRi Simulations being one of those, we can offer simulation services to augment our existing support offerings. So in conjunction with exercise facilitation and subject matter expert support, the addition of a simulation service adds another layer of realism when performing a source control exercise. I'm going to, in the next slide here, I'm going to pass this off to you, Des, if you want to give us an overview of who GRi are and some of your background, please. You're on mute, Des.
Thank you. GRi Simulations is a Canadian technology company founded in 1986, and we've been delivering high-fidelity simulation solutions for marine systems and offshore energy operations since 1998. Our main product, VROV, or Virtual Remotely Operated Vehicle, is a 3D interactive real-time simulation system which supports the complete range of AUVs, inspection and work class ROVs, more recently USVs or uncrewed surface vessels, and the full spectrum of sensor and intervention subsystems. Since 1998, VROV has set the standard in interactive real-time subsea simulation, featuring fully interactive tether dynamics, manipulator functionality, and high-fidelity sonar and graphics simulation. The video shown here is a rigid well jumper installation being performed by two ROVs working together to operate the twin connection actuation tools, which lower and lock the jumper on the manifold and tree hubs. This is one of the more challenging simulation scenarios from the first project I worked on at GRi nearly 20 years ago. And we simulated the installation and operation of all equipment in a major oil field in the Gulf of Mexico. These simulations were used by the ROV service provider to train their operators and perform pre-dive hazard identification studies and mission rehearsal to enhance operational awareness and reduce risk. Next, we'll have a look at a recent case study where we use the simulator to support an emergency response exercise. But first, some points on why it's useful. Simulation provides a safe environment to practice emergency response without real-world risks. The technology allows teams to test their response plans, identify weaknesses, and refine procedures. By simulating various scenarios, organizations can enhance their readiness and ensure effective coordination during real emergencies. Short of the actual mobilization of assets, use of this technology in source control exercises is seen by some as an industry best practice. So we'll have a quick look at what's going on in this video here now, and I will give a little bit of a description of what happened during this event. So back in October 2022, GRI were involved in a large-scale Tier 3 emergency response exercise organized by Occidental Petroleum in Houston, Texas. This event featured the MWCC, or Marine Well Containment Company's, capping stack to provide an interactive simulation of the well capping equipment installation and operation procedures. The different teams involved in the exercise were organized into breakout rooms where they could all watch the well capping simulations being streamed live on YouTube, with some groups interacting with the VROV simulation operator, directing the actions of the ROV to function the virtual equipment based on the outlined procedures. I piloted the ROV during these live simulations, and they actually designated one of the source control engineers that was sitting by me as my ROV supervisor. So he was responsible for reviewing the capping stack operating procedure and giving me timely directions on what steps in the sequence to do next. And this was based on continuous communications that our breakout group were having with the flow assurance team. And they were actually monitoring the pressures building on the capping stack gauges as the procedure progressed. The simulation was designed to mimic conditions of a particular well with pre-calculated pressure response curves that were integrated into the simulation. The simulation proceeded according to the operational plans until the full soft shut-in procedure had been completed successfully, stopping the flow of oil from the central bore of the capping stack. Feedback during the event's lesson learned session was seemingly unanimous that the simulator had provided a greatly enhanced and immersive exercise experience. Okay, so with that, we're going to give you a sample of what one of these live demonstrations looks like. Neil will be operating our VROV simulator. And just so everyone knows, we're operating out of Newfoundland, Canada right now. So we're on the other side of the world from some of you. So Neil's going to operate a virtual ROV, and we're going to do a site survey operation. So this is a site survey on an offshore asset that's just had an incident. We're going to go in and check it out and see what's happened there. So to get that done, like I said, we are going to stream this live to YouTube. So if anybody wants to try to connect on there, I am going to copy this link into the Teams chat, and you'll be able to go in through your web browser and watch it in there. But I will also be sharing my screen, and I'll also be logged into the YouTube stream watching Neil's actions. So if you stay in Teams here with us, you can just watch through there. And just a note, anybody who is going to click on the link or use the QR code on a mobile device or whatever to access the stream, please stay in the Teams call as well, so you can hear what we're saying. So that's the share link. I just pasted in the chat. If you click that, it should open another window browser where you can watch Neil's live stream software demonstration. But I will also switch over, and now you should all be able to see the stream coming through Teams as well. So before we get started here, just a quick look at what we're seeing, and then I'll let Brett and Neil kind of walk us through this little simulation exercise. So this is our VROV simulation software. You can see over on the right, there's a little control panel there where we can control some aspects. We can stop and start things. We can enter a user profile, and we can change environmental settings. And the main feature here, of course, are the 3 viewports that you see. Over on the left is the main ROV camera, which is a color cam. I think we have the sonar there, of course, and then the low light camera. So over to the guys, and I'll let you run through this simulation for us.
Okay, thanks, Des. This is Brett, and we've got Neil actually piloting the ROV for us tonight. So I just want to set the stage here. I'm going to take about 10 minutes to take you through a site survey. So put yourself in your exercise. You've assembled everyone. You know you've got a subsea blowout. It's evidenced by the oil that's on the surface, but you actually haven't been able to go down and actually look at what's going on right now. So the first mission that we need to do is we need to get eyes on task to look at what the environment looks like, to establish what the issues are, and then using the site survey, that then feeds into all of the other missions. So with that, Neil, I'm going to ask you to come out of the TMS, come down to the seabed and pick up on sonar, pick up the BOP and have you navigate towards the BOP along the seabed, please. So, in your exercise, this is a live feed on YouTube. So we can publish this directly into your common operating picture. So anybody who's on your common operating feed can see the actual the video itself. So what we're doing here is if this was in the exercise, we would have a mission plan. We'd have a certain list of things that we would want to achieve or assess as part of our site survey. One of them would be, first off, we want to check the inclination on our BOP to see if it's vertical. We really don't know the condition of everything yet. For this scenario, we do know that we had a DP runoff, and we don't think we had a successful LMRP disconnect based on the weights on the top tension on the drive. So looking here, we see the eyeball or the bullseye. This is a 5-degree bullseye. Each one of those stripes or circles is 1 degree. You count those from center. We're looking at 2.5-degree inclination. In this instance, the ROV, if you look at the video overlay up top, it's saying it's looking east. So that indicates to us that this stack is angled 2.5 degrees to the north, which ties in with the reports that we had from the drive off, drift off, that the actual rig went in that direction. So Neil, if you can start coming up, looking at the BOP, and as we're going up, if you can look at the BOP panel, one of the critical things that we need to assess when we're doing our site survey is if we have access to the BOP panel, because that's one of our critical missions for survey for source control would be to try to do a BOP intervention mission. In this instance, we would try to regain control of the BOP itself by using hydraulic fluid to try to close the rams, either the blind shear or the casing shear. And if we're able to regain control of the BOP and shut it in, well, then we can halt the flow. And that takes a lot of pressure off of everyone. But anyway, so at this stage, we haven't done that. But what we have identified is we do have access to the panel. So that is a viable option. So that's critical information that the BOP intervention team would need to take away. They would check to make sure that the ROV panel matches the PNIDs, et cetera, et cetera. Anyway, let's continue up here now. It's evident here that the LMRP wasn't disconnected because we're staring at it. So that's still there. And we keep coming up. And we'll notice we still have a riser. Okay, I think we found the source of the discharge for the oil. So right now we know that we have a debris removal mission staring at us. The first thing we need to do is we're going to have to try to remove this the riser section here, and odds are the recommendation will be to remove the LMRP as well. So from a debris removal standpoint, this is going to be pretty complex. But all of this stuff has to be done in advance of landing a capping stack. So just like, we're doing, we're identifying the inputs for the BOP intervention. We also, we need to start looking at the entire field here for debris removal. So yes, if you'd mind continuing coming down, I'd appreciate that, Neil. We're trying now to try to get the extents of the riser, how far away it is, how much is on the seabed, etc. Keep going. You got a tight tether there, Neil? Okay, we're starting to pick up some of the seabed here in the low light camera in the bottom right. And this is indicative of what you would see offshore. Okay. So we have a subsea architecture there. We have a tree subsea. We have the riser falling down. We actually have it looks like a chemical distribution assembly here, UTA, and we actually have the riser laying across next to it. So let's just head back up to the BOP, please. And so what we would do in this instance now, we would actually take a lot of time doing sonar scans of the seabed to see if there's any broaching. We would look at all of the other existing infrastructure to make sure that there's no damage. And then, of course, we would need to start making plans for removing the riser section here. We had to be very careful, of course, because of the infrastructure. But we would then we would go ahead and we would start planning for that mission. So I'm going to, I guess we'll sort of halt it here. We're going to go ahead and the next couple of slides, we're going to give you a high level overview of what the dispersant mission would look like, as well as what the a debris removal mission would look like. And we can go ahead to the next one. And with that, I'll just hand it back off to Des. And then I guess, Neil, if you can just go hang out in the TMS and we'll go from there. And then later on, we'll invite people to direct the ROV pilot to do things. Over to you, Des. And you're mute.
Thank you. I'll just skip back to the beginning here, and I'm going to pause this for a second, just so we can have a look at what's happening here in front of us. So, yeah, we have a pre-recorded simulation that we did for this part. We'll check back in with Neil near the end, and we can kind of do some extra things in that site survey scenario. But this is the debris clearance operations. So as you can see here, some of the pieces of the riser have already been chopped up and they've been stored in this wet storage zone, this area over here that doesn't have any field architecture. So you can see that there is a big piece of that riser still suspended there that we need to get rid of, and that's what we're going to go through, chopping that up and moving it to the wet storage during this simulation.
And just if I can interrupt there for a second, this doesn't follow directly on from the site survey, right? For your exercise, you may not want to start with the site survey. You may want to start with debris removal. You may jump forward 3 or 4 days into your scenario. You may want to take your exercise and actually do discrete segregated snippets, if you will, and jump forward in time to do these missions. We can do this either as part of a flop, as a full-on exercise, or we can work just with your site survey, your source control team and your reservoir team. Anyway, if you want to continue, Des, I just wanted to add that in there.
Yeah, no problem. So this video shows some highlights of the debris clearance operations. And as I mentioned at the beginning, this was created from pre-recorded VROV simulations. So beyond the diamond wire saw that we just saw the ROV operator using to chop off that big piece there, we have a wide range, maybe the full range of this debris clearance equipment from the SWIS toolbox. We also have the small handheld hydraulic cutters and grinders that you can use to cut up the small piping, right up to the um, larger equipment like the chop saw and the super shears and the pipe grappler. So yeah, just back to the video. You can see here that before we cut this off, we had this large piece of riser that was left there pre-rigged with soft slings, so that of course once it was released, it didn't crash down upon anything. And yeah, of course, there's a little note there. It takes quite a while to cut through a big piece of pipe like that, even with a fancy diamond wire saw. But we have sped up for the simulation, of course, just to save time. And of course, you can see once the cut is made that the flow actually stops coming from that crack up at the top and now starts coming out of this new cut that we've made. So then once that has been released, that's also just going to be dropped off. The ROV operator will guide the vessel and the crane operator into position so that they can lower this into place in the wet storage zone there. And now we'll take a look at the next step that we have defined in this sequence, which will be some dispersant operations. Now, before I go on here, I'm just going to do a quick pause and have a look at what we got going on before we proceed. You can see after we chopped up this riser and moved it to wet storage, now in between that last piece we saw and the dispersant that we're going to do next, they've also removed the LMRP and transported that and lowered it into the wet storage zone also. And some of the dispersant equipment has already been installed, and the equipment has been connected together with the flying leads that you see here plugged into the ROV panels. So after the dispersant deployment frames have been deployed and connected, the final step is what we're going to see here, which is actually actuating the flow of dispersant from the wands here and placing that into the flow of oil that's coming out of the BOP mandrel. So there's a couple of different styles of these wands that we have in the simulator. We have, I think, 3 different radius of this hook style dispersant wand, and we also have the handheld wand that an ROV operator can just hold their manual flying on point and holding the wand into the dispersant with the ROV as opposed to hooking on like this. Okay, let's click over to the next step in the process. So this video, this is actually bringing in the capping stack. Now that we've got the debris out of the way, we've had some dispersant kind of injected into the plume to reduce the effects there. Now we're going to bring in the capping stack and try and shut this thing off. So this video, most of the other videos we watched were captured recently. This was an old one actually that we did right back with Subsea Well Response Project before it changed over to SWIS. And this is what was delivered with the kit back then. So the ROV pilot, of course, picks up the capping stack here in the water column and is going to direct the vessel and crane operators to get this into position directly above the BOP mandrel. Of course, this capping stack, the SWIS capping stack that we see here was made by Trendsetter down in Houston. We've been working with them since they started making these capping stack equipment for subsea well response and marine well containment that we saw earlier in the Occidental case study. I'll actually click through a few of these, skip ahead a little bit just so we can see what happens.
And for people familiar with the OSRL asset base, this would be either the Brazil stack or the Norway stack. Both of those would be the RAM-based 15K capping stacks.
I think we've done a few of the other ones too, Brett, maybe the 10K and possibly rapid cap.
Yeah. So you've got ours. You've got the Guyana stack that we have, which is different from this. You have that one model as well, which we can utilize in scenarios. And then you have the MWCC and the HWCG stacks as well here in the GOM.
So it looks like we're right over the mandrel here now. Next step is just to lower this into place until it starts taking up some slack in the rigging. So I'll just click ahead here till we have it landed out. Of course, these operations take a lot longer than we're seeing here on the videos. So once we're landed out, we want to go through the process to function the valves here to latch the capping stack onto the mandrel. So the pilot, of course, or the ROV supervisor who's directing the pilot would be reviewing the operations procedures and going step by step to open and close these valves in sequence. And then we can actually see the pressure gauges build and stuff. We can see the control fluid coming out of the designated valves and that kind of thing. So it's a really advanced high fidelity simulation that kind of looks at every aspect of the procedure, right? All of these suspended dummy stabs, the control fluid. And as mentioned before, this can be tied into, pressure response analysis that's been done previously on a per well type basis. So beyond just landing out the capping stack that we're seeing here, okay, it looks like the latch has been engaged and we're going to release the rigging now. But beyond installing the capping stack, we have simulations that go through the full procedure of operating this thing, including contingencies for things like, changing out gaskets, swapping out one of these choke legs if we have a problem with them. But the operators get to go through the full set of operations to close off each of the choke legs in sequence, and then finally actuate the rams to stop the flow of oil coming through the central bore there. So last step, the running tool has been released, and that's going to be recovered to surface. So capping stack's been installed. Now only a couple of steps left, and we'll have that thing sealed up. Okay. Back to you. I'm not sure if Brett or Mario wants to take this one, just to sum things up a little bit before we switch back over to Neil there.
Brett, you want me to take this?
Yeah, go ahead.
Okay, so just a quick one on the software and the demo and what you've just seen. Obviously, this is a value adder. It allows for that cross-team collaboration. It links up within that source control branch, the flow engineering team with the subsea team and other elements of the source control branch. It provides a real-time display during the exercise of that subsea environment and puts that sort of heightened sense of realism into the exercise. So all the various missions required to cap and shut in a well are represented in the simulator, from the earliest piece where you saw the on-site site survey all the way through to capping stack deployment and obviously operation that you just seen there. And so it really puts the subsea well response, capping, and the other various missions associated with capping right front and center for your exercise. And really importantly, and really wanted to highlight this, is that the source control team works hand in hand with the ROV pilot and supervisor to direct those missions in a realistic simulated environment. So it provides that really heightened sense of realism in your exercises. So I think essentially that's kind of what I wanted to say. Brett, is there anything you wanted to add there?
Yeah, I mean, specific to the capping stack mission, when we start doing the soft shut-in procedure, this is where it really, really shines through, because not only are we then engaging with our source control team, but we're also engaged with the reservoir team. And the reservoir team, they're constantly monitoring those gauges as we're performing the shut-in, and they're constantly monitoring against pressure response curves and the expected pressures. And if everything's going according to plan, it's great. We can shut it in and kill the well, or not kill the well, but shut in the well and everyone's happy. But one of the good things that we can do with this simulator is we can actually put faults in there, or we can misreadings. And what we did for the Oxy exercise is on that last choke shut in, it didn't follow the same pressure response trend. It was falling, it was well below what the expected shut-in pressures would have been. And this then prompted the reservoir team to call an all stop on the shut-in because there was potential for broaching. There was something was going on that didn't match what the expected pressures needed to be. And this was when this really came into its own, because now you had the reservoir team scrambling to look at contingencies to see what could potentially, what scenario could match that. You also then had the subsea team going, well, maybe it's not the reservoir, maybe the choke is washing out, and that's why the pressures aren't what are expected. So it led both teams to start really revamping and looking at the scenario that they're dealt with and start trying to really work the problem. And so what they ended up doing is in the mission, the subsea guys decided, okay, open that choke back up, open the other choke back up, close, isolate this choke leg, the questionable one, and then try to redo it again and see if it's choke washout. While they were doing that, the reservoir people, et cetera, et cetera. So without belaboring the point, beyond just this is what it is, in any of these missions, we can throw curveballs in there to really help you work your teams. And when we'd finished that, that was a lot of the goodwill that was presented to us was based on the fact that these people all felt challenged. And when they finally shut in that stack with the numbers that made sense to them, there was an actual sense of achievement. They honestly thought they'd done something. So that's all I wanted to add to that.
No, thanks, Brett. I think,
Thanks.
Yeah, it's really good because, when we run these source control exercises, they come in various shapes and forms. But this element can be added into any part of an exercise, or could be just standalone for elements of your source control team, or a number of elements in your source control team that Brett's just run through. So you can think about it in many ways. You don't have to have it in a massive exercise. You can actually scale it into just some source control exercise for your source control team on its own if you needed to. So it lends itself to various exercise sort of models. All right.
And I think that's reflected here. Des and Neil are in St. John's, Newfoundland. And in the next slide here, we're going to go back to the live demo again. And I'm going to ask Neil to sort of free fly and give us a flavor for all of the strengths, I guess, if you will, of the actual the simulator, because it's more than just what you see at the seabed. There's a surface component. But if we can go back and Des show the live feed again.
Yeah, I'll flick back there. Anybody who was following along on YouTube, if you use the YouTube link and you're coming back to it, you want to click on this little live button here. Usually it will say, will show a red circle, but if it's not actually live, it'll be gray. So you just want to click that to refresh. Like it just happened to me, we saw a little bit of buffering, and then my live dot went to gray. So just to bring us back to live. Okay, Neil, you were on again. So Neil's back. He's just hanging out in the TMS there while we've been having a chat. But now we can probably switch to the aerial view, Neil, and just give everybody a look at the scene. We kept this to the ROV cameras and sonar view. Initially, because you don't usually get to see this kind of aerial God's eye view that we're looking at here now. So it's really immersive having the actual ROV coming up on the first site survey where you see the equipment kind of coming out of the darkness, and it's very like first eyes on. So you're really it's shocking when you kind of see the damage that's been done. So here we are. We have a pretty fully fleshed out field here with a couple of manifolds. Looks like there's about eight or 10 wells, maybe 12. and a couple of plets running off, maybe to an FPSO or something like that. And there's the UTA. So we have the UTA that's kind of underneath the downed riser there in a precarious position. So yeah, so this is just a generic oil field that we're using for this demonstration, but this could be your oil field, right? We can customize these simulations so that they use real world bathymetry, and the scene is georeferenced to your location. And we could actually have your equipment models in there, all connected up the way that they are in reality. So basically an operational digital twin that we could run these simulations through. Yeah, so Neil, just go over and I guess have a look around at a few things. We had a couple of things that we wanted to give a show of. Oh, sorry, I got to click back to there. Yeah, well, why don't we go up to the ocean surface, Neil, and just see what's going on up there. We got some of the surface vessels up on the top there, and that's what's actually been used to deploy the ROV here, and I think one of them might be used in the later scenarios for as a dispersant vessel. We can also change things in the simulation, like environmental parameters. So using this control panel on the right here, you can see there's a bunch of settings. I'm buffering again, Neil. All right. You can see there's a bunch of settings there. Neil, you can just go through some of those sliders. Time of day is the one he has grabbed there. We can make this so it's nighttime or morning. I'm getting a little bit of buffering here now, Neil. Okay, there he goes. We got nighttime, daytime. How about the fog and the rain? We can bring in some fog. We can bring in a storm. Make it look not so nice out there. This is the weather we usually get around Newfoundland. It's like this 75% of the time where we're from. And we can also change the sea state. So this is a level of difficulty here. So things like the sea state based on the Beaufort scale, like you see here. We can also change the underwater current, speed and direction, so that the ROV pilots would actually have to struggle against the current to get from point A to point B. And if the vessels are heaving like this, of course, anything suspended from the vessels will be reacting accordingly. Neil, you can go down subsea there and just look at the TMS. So yeah, you can see now that we're up at Beaufort 5. The vessels, of course, are rocking back and forth, and the tether management system here is heaving up and down. We can also implement active heave compensation for any cranes that might have that enabled in the simulator to get realistic effects like that. What are things? Well, we can show the field layouts, right? So, we have all these nice 3D models here, but these are all positioned, according to real world field layouts. Those usually come in 2D files, maybe a drawing or a GIS file. We can import those into the software, and we can overlay them on the ocean surface or on the seafloor. I think for this one, we just probably have them overlaid on the ocean surface, but we can take them layer by layer and actually, kind of drape them over the terrain if we want to, or have them kind of project through pieces of equipment, whatever makes the most sense visually. So you can see this is our layout here. We have an operational layout that we can bring up when needed. And this can also, we're doing this live simulation. It's a simulation, but we can also set up the software to be more of a real-time monitoring solution, where we're taking real-time positioning data from vessels, ROVs, any equipment that has a transponder on it, and we can give this kind of view in real time as a real operation progresses.
Yeah, so let's speak about that for a second, because if you have surface vessels, and I'm looking, we can take the live feeds if they're available, either through AIS or whatever. We can display them in this, and then we can feed this into your common operating picture as well. We can also present on the surface here if you have trajectory modeling for some of your for your spill. We can model that into this system as well. So it is a full 3D immersive environment. It's not just an ROV simulator at the seabed.
Some other interesting features of the software, we can take, well, log files, of course. A lot of those videos that we saw of some of the other procedures were captured from recorded or logged simulations, and then we can play those back. You can rewind and fast forward to get to points of interest. We can also take snapshots. So you could kind of take a snapshot anywhere during a simulation so that you can restart for that same position again. We like to do an interesting one called shift change, where you kind of put the ROV into a horrible position, maybe wrap the tether around a couple of pieces of equipment, then you take a snapshot, and you get up, you're done your shift, the next guy has to come in and kind of figure out what to do with the mess you just created. Yeah, and what about grabbing onto some stuff, Neil? Can we grab the ROV panel there? Just to show it. The dynamic fidelity of the simulator is very good. We can do a lot of really complex interactions, multiple vehicles, multiple manipulators, handling articulated equipment, ROV hooks and shackles and that kind of thing. So you can really get a lot going on in here. It can have some seriously challenging simulations that you have to really focus to get through. Very wide range of tooling, of course, hydraulic hot stabs, cutting tools, cleaning tools. You know, most operations that an ROV pilot would face in reality can be simulated in here for rehearsal. We were kind of planning on getting some attendees, I think, to direct the ROV pilot, but I don't think anybody's able to provide.
Well, what they can do if
feels
someone's interested, if they want to raise their hand, I can unmute them if they want to speak, or if someone has a particular question they'd like to ask, we open it up to the floor now. Just raise your hand and I'll unmute you.
Or put it in the chat, Brett. I think.
Yeah, you could type in the chat.
Or you can type it
into the chat. Yeah. Even if you want to direct the ROV, if you want to direct Neil into doing something, put it in the chat, and that's probably the easiest way.
Sure.
I'll give them the first direction. Neil, why don't you go down and just put the ROV down on the seafloor next to one of the trees, just to show some of the dirt kick-up effects once you get down there. And then before you come up, maybe snag your tether on the corner of the tree or something like that, just to show that type of interaction. We also really put a lot of effort into, getting the lighting correct. Even so far, I think the programmers, the latest pass it on the lighting. They even introduced the effects of different amounts of chlorophyll in the water, so that some of the backscattering thing comes through as green or blue sometimes, depending on the chlorophyll levels. So you can see here as Neil is putting this vehicle in a horrible situation. You'd never do this in reality, of course, but he's just kind of skimming off the seafloor there. You can see the dirt clouds getting kicked up. So you can sometimes a pilot will kick up some dirt there and either have to kind of sit in that cloud until it goes away or fly up out of it. Just showing some of the tether interactivity here. Of course, if you aren't paying attention to your tether and you go around doing a couple of operations, you could, hopefully not in this horrible situation, but you could easily get your tether snagged on a piece of equipment if you're not paying attention. So that tether management skill is one of the main skills an ROV pilot has to learn. So it's a very important feature to have that dynamic fidelity where we can show all of those challenges in the simulator here. What about the current, Neil? Have you turned on the ocean current yet? Did we show that one already? Be good to show it here now while we got the ROV next to a tree. Of course, we are snagged, so let's just turn on the ocean current. So once Neil ups the speed here, we should see the vehicle getting pulled away. Yeah. So, during training, we have the ability to put the training objectives up on the overlay here and kind of step by step guide the trainees through. And then at the end, we can output a summary report based on if they got all the tasks completed and the time to complete each task. But then we can introduce levels of difficulty. And one of the things to up the difficulty is to increase the ocean current. And we can also do things like increase the sea state and bring down the visibility so it's hard to see from far away. So why don't you give that a shot, Neil? Just change the visibility slider there so you can kind of hardly see that tree from where you are there now. I'm buffering again. Okay, I'm caught up. Okay, so yeah, Neil, oh, there it goes. We almost lost the front of the manipulator as well. Yeah, so it's a bit harder to see. So yeah, as you can see, really full-featured simulation software with considerations for a lot of different aspects of the environment and the functioning of the equipment. This is really pretty important, of course.
All right, thanks, Des. I think probably at this point, maybe just encourage the audience to post any questions they have, or if you still want to, direct Neil to do something specific with the ROV, you can do that. But we'll just open it up to the floor. We've got about just over 10 minutes, 13 minutes left. Is there anything in particular anyone wants to ask? Or I've just got the chat open now.
A couple of other notes, I guess. Neil's currently flying using, I don't know if you'll be able to see this, but just an off-the-shelf gaming joystick. Just for this quick little demonstration. But we also have the ability to do a full integration into the real-world control system. So the pilots, operators will be able to use those during the simulations to get that real hands-on feel.
All right. I'm not seeing anything come up on the chat. Give everyone a few more seconds. Anything you want to post?
Yeah, so the real intention here was just to kind of demonstrate, that this was a live session, right? I think that's been apparent as we've been directing Neil around to do different things. We only covered a small, I guess, aspect of GRi's capabilities. So at the end of the session here, I'll just put another link in the chat, and that'll allow you to access another slideshow that just gives a little bit more detail on some of the other things that GRi has been involved in over the past 10 to 20 years.
Thanks.
But yeah, that probably brings us to the end there, Mario.
Yeah, thanks, Des. Thanks, Neil and Brett. We might just go to the last slide. Just click over.
Yes.
So there's some context there. So if you want more information, there's Brett's email address and there's Des's email address that you can ask further questions. If you come out of this later on thinking, I actually want to try this. I don't have my email address for those in the APAC region, but for those of you probably on the call, a lot of you know who I am and you have my email address. Happy to answer any questions as well, but you've got direct access to Brett and Des there. I'd like to thank Neil, Des, and Brett for coming on and conducting the webinar and demoing the product. We want to value add to our OSRL exercises, and this product provides that extra sort of enhanced realism into an exercise. So, we really are quite happy that we're working with GRi and have been engaged with GRi over the time since the inception of this equipment, the capping equipment. So it's been really good. I'd like to thank the audience for coming on as well. I appreciate your time. Everyone's busy. We've got busy schedules, but appreciate you coming in, listening in, and seeing this demonstration. So thank you. I might pass over to Brett, Des, and Neil for any closing comments, and then we'll call it a day.
Yeah,
Brett,
just to mimic what you've said there, Mario. I appreciate everyone's interest in attending this webinar. This is technology that's near and dear to my heart. It's something that I started when I was at BP 20 years ago, which was the original missions that you saw there, and the technology it's really been integral to a lot of the subsea development work that I've been involved with over the years. Just one thing to remember, right? So technology has advanced. 20 years ago, it would have required two guys, racks of computers, et cetera, to achieve what we've been able to achieve tonight. And we wouldn't have done it in a team setting by any stretch. But nowadays, these guys, as long as they've got a gaming computer and a joystick, they can replicate everything that we saw tonight. And now with connectivity the way it is, we can be pretty cost effective if you're wanting us to help you with your exercise. I'm sure the guys would like to fly to Singapore, but if budgets don't allow, we can still do it remote, either in Houston or in as well as St. John's, like we've done tonight. So I think we could be pretty cost effective. I don't want people to be scared away by the technology thinking it's expensive. I think the value add is there. You've got my email here, so please reach out. And to Des, I'll hand it over to you now, Des.
Yeah, thanks, Brett and Mario. Just want to thank everybody for joining and paying attention during the presentation. I have shared a link in the chat there to an additional presentation, just showing a bit more highlights of some of GRI's capabilities. And yeah, it's been great kind of seeing the technology grow over the years. Brett and us at GRI, we've become friends working on these things together, since his days at BP. And it's great just to kind of see it come full circle now at OSRL with the guys introducing our technology for these emergency response exercises. So thank you very much. Very exciting to be a part of it, and hope to work with some of you in the future for supporting your own exercises.
Thanks, Des. Neil, anything you want to add before we close out?
No, I mean, again, thanks for hosting and for everyone's attention during the demos.
Excellent, thank you. All right, I think we'll draw it to a close. Thanks everyone for attending. As I said, reach out to Brett, Des, or even myself if you've got any questions, and appreciate your attendance. Thanks everyone, and see you next time.